Recording in progress.
So we started doing the checkups of the chapter number 1, and in that we
Yes.
have completed the question number 1. Now moving on to the question number 2. Here they have mentioned that a large crystal of potassium manganate was placed in the bottom of a beaker of cold water. Now what they are saying, that there is a
Just
crystal.
give me 1 minute. My dad is calling.
Sorry.
My dad is calling me. Just give me 1 minute.
Okay. Okay, over here we have question
Recording in progress.
that a large crystal of potassium manganate was placed in the bottom of a beaker of cold water and left for several hours. Okay, this one. Now what they are saying,
Yeah.
you have crystal of potassium manganate and you have cold water. Describe what could be seen after 5 minutes. What could happen after 5 minutes? In this check one, you see they have mentioned that the movement of the, firstly, we have discussed about the diffusion. What is diffusion process?
Yes. Something that goes from a high concentration to a low concentration.
Yeah, the movement of particles from the area of their higher
Yeah.
concentration towards the area of lower concentration.
Lower
Okay,
concentration.
so the purple color, as you know, the potassium manganate is purple in color. Okay, so when after some time, after 5
Yes.
minutes, what will happen? This crystal will start dissolving. Okay, it will start dissolving in the water, and once it started dissolving, what will happen? The color of the solution will change. Okay, after 5 minutes the color of the solution will be light purple, right? Because after 5 minutes it means that we are checking in the start of the reaction, like you have taken the cold water and you have placed the potassium manganate in that. Okay, and after 5 minutes what you observe is that there is light purple solution. Clear?
Yeah.
What will happen after several hours in this? After 5 minutes there will be light purple color, and after several
Yeah.
hours what will happen? The
There
color
will be
intensity
full
will
purple
increase
color.
or decrease?
Increase.
Yeah, so we will say that the after several hours the solution will be dark purple in color. Okay, like there will be it will spread out. Initially at 5 minutes there will be, maybe after 5 minutes it is not completely dissolved, right? But after
Yes.
several hours the potassium manganate will be completely dissolved, right? And you will have a uniform purple color. Are you getting this?
Yeah. Yes.
So after 5 minutes your answer will be that the crystal of potassium manganate will start to spread. Okay, will start to spread after 5 minutes,
Yes.
and after several hours there will be a uniform purple color. Okay,
Yes.
clear?
Yeah.
Okay, now in part B they are asking, explain your answer using the idea of particles. Now can you tell me what is happening, like why
Like
there
less
is.
part, like
Mm-hmm.
because like of the maybe of the intensity, it goes like the particle goes from together to like
Yes,
far apart from each other.
you what we can say in terms of particles is that initially the particles are condensed, okay, in this region. The crystal of potassium manganate over here, what you will write in the bottom of the beaker, the crystals of potassium manganate are more, they are dense, they are condensed, their concentration is more, right? And after
Yeah.
some time what will happen, the
Yes.
particles will start to move in the liquid, and after several hours the liquid will become completely purple. Okay, there will be a uniform purple color in the liquid. It happens because the particles are moving in the
Yeah.
liquid. Okay, the particles of the potassium manganate are moving in the cold water.
Yes.
Okay, they are dissolving in the cold water. Clear?
Yes.
Again one more time,
Yeah.
potassium manganate is made up of particles, as you see. When it will be placed in, what will happen? These particles will, firstly, the particles are condensed in this region. They will start dissolving. Okay, they will start dissolving in it, and they will move randomly. They will move randomly in it, and after several hours, there will be a complete uniform purple color. Clear? Okay. Now part C. Name two processes that took place during the experiment. Okay, what are the two processes which are happening?
Diffusion.
Yes. And diffusion means particles are spreading. Okay. And what is happening? How we gain the? How we have this purple
yes,
color?
yes.
You know what happens, like when you have
Because
red color dye
it
and you
went
have
from
blue
a high.
color. Yes.
No.
It is dissolving. Okay, mixing. Because how you have a
Yeah,
different color.
so the two processes are dissolving
And
and diffusion.
yeah, dissolution
Diffusion.
and diffusion. So the first process is diffusion,
Yeah.
and due to this diffusion, the particles will start to dissolve. So second process is dissolution. Clear? And because of this dissolution,
Yes.
we get this color,
Yes.
the purple color or blue color, or in any solution, in any whatever the solution is, we have different colors. Why we have different colors in this solution? Because there is dissolution process. First step is diffusion. The particles start
Yeah.
to diffuse, and second is when those particles diffuse into different areas, they start to dissolve in those areas, and thus the solution become colored.
Yeah.
Clear?
Yes.
Okay.
Yeah.
Use the idea of particles to explain why solids have a definite shape. Yes, why solids have definite shape?
Because it's lasted and like the particles are very near each other.
Particles are close to each other.
Particles are
Yes.
close to each other, and it's a lattice shape.
Yes, there is a lattice. In solid, we have discussed that in the solid there are strong forces of attraction available, right? The particles are attracted to each
Yes.
other, and there are no free spaces available in the solid.
Yes.
So the particles are packed very closely together in a fixed pattern, in a regular pattern, and that is known as lattice. Clear? That is why we say that
Yeah.
solids have a definite shape. Okay.
Yes.
Second, part B. Liquid fill the bottom of the container. What does it mean?
Look.
Like whenever you pour a liquid in a beaker, whatever the shape of the beaker, like for example, you have a beaker, or you have a volumetric flask, or you have any cylindrical shape beaker, right? Any other beaker.
Yes.
Whatever the shape of the beaker, but when you pour the liquid in it, what happens is that we see that liquid fills in the bottom of the container, right? Have you observed this? Like
Yes.
when you take water in a glass, or whether you take water in a jug, or whether you take water in a plate, or in anything, what will you see? That the water will be in the bottom. Why is this so?
Because it's like a fluid.
Now think in perspective
Maybe because
of in terms of the particles, right? Yes.
the particles are like a bit far apart each other, so it's easy to flow.
Yes. Actually, as you told that the particles in the liquid are close together, but they are arranged, but they have random arrangement, right? So the forces between them are weaker as compared to the solids, right?
Solids.
So that's why these particles will slide past each other. Okay, these particles will slide past each other,
Slide past.
and when they will slide past, they will fill the bottom of the container. Clear? They will fill the bottom of the container, because after this they cannot slide past. You see this last particle, it cannot slide past. The last particle in the bottom,
Yes.
it cannot slide past. So this is what we say.
Yes.
Whenever you have a liquid and you fill that liquid in a container, what happens is that liquid fills in the bottom, Because the particles of the liquid, they slide past each other
Mhm.
because they have some free spaces available. That's why they slide past
Yeah.
each other, right?
Yes.
Clear?
Yeah.
Okay, now we have, you can't store gases in open containers. Yeah, why is this so?
You can store up in a, because like the particles are far apart each other, and it's easy to like the gas will just go out of the container because it's far apart each other.
Sorry, what you said? Can you repeat it?
Uh, yeah, I was saying that like the particles in the gas are like the particles in the gas are like far apart each other,
Yes.
so it's
They are
there's
randomly
like
moving, right?
so
They are
it's
randomly moving in different
yeah.
directions.
Yes,
And yes.
I was saying like gas particle like, and they're like they have weak
Hmm.
forces of attraction,
They have
so
very weak. You
it's
can say
easy
they have negligible forces of attraction. Negligible means you can neglect. They
very
have
weak. Yeah.
very less forces of attraction because they are far apart from each
Yes.
other. Like for example, you have a
Yeah,
particle over here, right? You have second
and
particle
they
over
move
here.
in random direction.
Sorry.
They move in a random direction.
Yes, you see these two particles, the particle A, particle B, they are far apart
Yeah.
from each other. So there will be minimal attraction in them. That is why whenever
Yeah.
you have gases, they are randomly spread out, and
Yeah.
you can't store them in a container because they have initially, first thing, you know that the gases have high kinetic energy. You know this thing we have discussed, that the
Yes.
kinetic energy of gases is very high, so that's why they move in random direction. They move in random direction with rapid speed, with increased speed. As I told you, the kinetic energy is totally dependent on the speed. Like if you want to check the speed of something, you see the kinetic energy. If the kinetic
Yeah.
energy of that particular thing is high, it means its speed will also be high, right? So
Yes.
in the gases, they have very high kinetic energy. It means their kinetic energy is very high, so they can move with a very high speed in different directions. That's why the
Yes.
gases, they one thing is that they're randomly moving, and second thing is that they are moving with a very high speed. Okay,
Mhm.
and there is no attraction. That is why they can spread out in all the directions, and they can,
Yeah.
and that is why they escape the container. They don't remain in the open container. Clear? Are you getting this? Like
Yeah.
for example, if you have
Yes.
this much large container, right, and you have taken one particle over here, there are different particles, but since they have very high speed and they are randomly moving, so they will escape the system. Okay, they will escape it because this is an open container. Clear?
Yeah.
Okay, next part, you can't squeeze
Can I just have 2 minutes? My mom is calling me.
okay, in this part
Recording in progress.
they have mentioned you can't squeeze a sealed plastic syringe that is completely full of water. Why is this so? Think about it. It's related to part
Um,
B.
maybe
Yes, it's quite
part.
similar.
Uh,
Like the concept is similar to the part B.
oh,
But
what happens at the boiling point of the substance?
they're asking that you can't squeeze a sealed plastic syringe. Have you seen the syringe? Like
Oh, okay.
when you completely fill the syringe,
Yeah.
yeah. But you cannot squeeze
Yes.
it. Why is this so?
Maybe because like the particles are
They are
like
saying that it's
together.
completely full of
They're like
water.
far apart from us.
No, 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 no.
Oh, full of water.
The syringe is
Okay,
full
so
of
it's full
water.
of water. So
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 can
they'll
you squeeze it then?
so wait.
Like
We could say that
I think you don't understand it. They are saying like, let's suppose this is a syringe, right? This is a needle. Over here you have that push thing, right? Have you seen the syringe?
But wait,
But if
yeah, I
you
know, but let
completely
me,
fill it, so you cannot push it, right? You cannot squeeze it. Why is this so?
yeah, maybe because of the like particles are very close to each other, so it
Yes,
doesn't have,
it's already filled.
they don't have space.
Yes, there
Yeah,
is no empty space so that you can move this plastic syringe. You cannot squeeze it because there is no space inside.
yes,
Already the particles are very close to each other because you have completely fill it, right?
yes.
There is no room, there is no empty space to push the particles. They are already in the compressed form. Clear? So this
Mhm.
liquid is incompressible. This is known as that when you have this syringe full of water, you will say now liquid is incompressible. You cannot compress it. Why you cannot compress it? Because there is no free space. Okay, there is no free space
Yeah.
available for the particles. Clear?
Mhm.
Are you getting this?
Yes.
Okay. Now in part E, a balloon expands as you blow it into it. Why?
Um, you can squeeze. Wait, no. Balloon expands when you blow it. Maybe because like there's a lot of gas particles inside of the balloon, so like they move a lot, and they move in all directions.
Yes.
That's why
As
it blows,
mm,
because it has a lot of particles.
when you blow it, what happens? You are increasing the number of gas
Yeah,
particles, right?
increasing.
You are
Yes.
increasing the
So
number of
it gets a
particles in the
lot, and
balloon.
then
Yes.
when it can't, like when there's a lot of there's no space, it blows up.
No, you how you will answer it? Your concept is clear, but how we will answer it?
Mhm.
A balloon
Maybe because we could say
expands as you
because
blow into it, right?
yeah, when you blow into air into a balloon, there's
What
like
will
a lot
happen?
of gas particles,
Yes,
and like they move rapidly in all direction. That makes the balloon cannot have more
inflated. That
space, and
makes the
it blows
balloon
up,
inflated.
inflated.
Yes.
Yeah.
Basically, what is happening when you are filling the gas in it, and when you are blowing it, actually you are filling the gas in it, right? And when there are more
Hmm.
particles, the particles will strike with each other, right? And as well as they will
Yes.
strike with the walls of the balloon, right? They will strike
Yes.
with each other as well as they will strike with the walls of the
All of
balloon.
the balloon.
Clear? So
Yeah.
when they exert pressure on the when they strike with the wall of the balloon, they exert pressure. Okay, they exert
Hmm.
pressure on the wall of the balloon. That's why when there are very when you blow it up to its limit, what will happen? After that, the balloon will burst. You know why it burst?
Yeah. Uh, because because it has no space because of the gas particles. It gets a lot and a lot when you blow air into it.
When you have filled the gas in it, right? When you are blowing it, so
Yeah.
there are more gas particles inside, and those gas particles will increase the pressure inside. Okay, they will increase the pressure
Yeah.
inside. Okay,
Hmm.
and when the pressure will increase, what will happen? If
When
the
pressure will
pressure will
increase, it will
increase
blow.
beyond its limit, the balloon will burst.
It will blow up. Yeah.
Yeah, it will burst. You know,
Burst.
it is a natural process. Whenever you want to do something beyond the limit, what will happen? The thing will break, right? So similarly, if there is a balloon and you are filling the gas in it, but you are filling it, there will be a limit for the balloon to have the gas
Yeah.
particles. After that limit, when you further increase the gas in it, the balloon will burst. Why it will burst? Because the particles will
Because
exert the pressure on the walls.
yes,
Okay, so when there are more particles, the more particles will exert pressure, and thus the balloon, initially the balloon will inflate, and after some time it will burst.
yeah,
Okay.
yes.
Okay, now they have mentioned that below is the heating curve for a pure substance. It shows how the temperature rises over time. Okay, how temperature rises over time? When the substance is heating until it melts, then boils. In question 1 they are saying, when, what is the melting point of the substance? Can you tell me what
Melting
is the
point of
Mhm.
1.5.
Is this melting point?
No, no, one. One is
Yeah, 1 is the melting point. Okay, at this it started
yeah. So
melting. Why you said this
1.5 is like evaporating point or whatever.
boiling, that is not
Well,
evaporating, that
yeah,
is
boiling.
boiling. Yes, boiling point.
Yes.
Okay, good. What is the reason behind this, that the boiling point and melting point there is a constant temperature for few minutes? Why is this so? Why we have
Because
constant temperature
it
for
takes a
few
bit of
minutes?
it,
Mm-hmm.
it takes a bit of time so it can melt and go from solid to liquid.
Yes, exactly. At this time, at this temperature, the temperature will be fixed because, like for example, there is the melting point is 1 degree, 1 degree, right? So
Mm,
at this temperature,
yeah.
the energy which is present in it will start. The solid will act on the solid so that the solid can convert into liquid. Okay, so the
Hmm.
energy in it is being utilized to change the state from the solid to the liquid, right?
Liquid, yeah.
That's why for few minutes the temperature will remain constant. Afterwards, when the solid is converted into liquid, what will happen? The temperature will start increasing, right? And there will be a
Yeah.
point at which the boiling will start. And similarly, as we have discussed for the melting, in the boiling there will be a constant temperature for few minutes. Why is this so? Because at this temperature the the energy in the particles is being used to change the state. Okay, the energy is used
Hmm.
to convert the liquid into gas. Are you clear?
Yes.
Okay, then what happens to the temperature while the substance changes the state?
Uh, what happens?
Hmm.
It well, the temperature
Think about it. What happens to the temperature?
it gets higher. It gets higher.
No.
No, it doesn't like the temperature go from like a low temperature to a high temperature when like the substance is changing.
The temperature will remain constant. They are saying what
Oh,
happens to the temperature while the state is changing. Okay, while substance is changing
oh,
the state, like
okay.
this. You
Hmm.
see, from solid to liquid. At this stage, I told you, in this point, what is happening? Why we have constant temperature? Because at this time, the energy in the system is used to convert it from solid to the liquid, right? That is why this is a
Yeah.
constant temperature. And similarly, over
Hmm.
here, we say that the temperature is constant because at this time the energy in it is used to convert the liquid into gas form.
Yeah.
Clear? Are you clear with
Yes.
this concept? Why the temperature will remain constant?
You told.
Okay, so we will say whenever there is a state change, the temperature will remain constant.
Constant.
Clear?
Yes.
Okay. Now the graph shows that the substance uh, the graph shows that the substance takes longer to boil than to melt. Suggest a reason for this. Yes.
Uh,
Over here, if you see,
yeah.
it takes longer time as compared to this time. Over here, you have just this time, right? You have just this time. but for this
Yeah.
the time period is much more, right? Time period is much more.
Yeah.
Why is this so?
Maybe because of like uh, um like liquid. How
Because
can I explain
maybe
this?
we will say at this mm, is this is so because at this stage we have more liquid particles and they need more energy. Okay, it takes more
Yeah.
energy to convert the liquid into gas. Okay,
Yes.
that's why it is time taking. When there are more liquid
Yeah.
particles and they need more energy, so your temperature remain constant, but temperature remain constant for more time as compared to the previous time, right? It takes more time.
Yeah.
Okay, next we have, how can you tell that substance is not water? Okay, by watching this graph, what can tell you? How can you tell that the substance is not water? Or not by
Because
singly, I'll just randomly, if someone asks you that how can you tell the substance is not water?
because what's it called? The boiling point of water is exactly 100 degrees.
The boiling point is 0 degree, right? You know, as you see,
It,
melting point is 0 degree and boiling point is
yeah, and boiling is 100 degrees.
100 degrees. So you see over here, this is not same. It is
Yes.
melting at 1 degree and boiling at 1.5 degree. That is why it is not.
Water.
Yeah, it is not water. Maybe it is something else. Sketch a rough heating curve for pure water. You have done this, right? You have done so many
Yes.
times. The heating curve. Did you practice it? I gave you the homework
Yeah.
when we were
Yes.
doing.
Yes.
Okay. Okay, now next we have question number 5. That is a cooling curve is the opposite. We will start this in the next class, okay? Because there is less time and